Hey guys, we're going to be launching into the beginning part of Chapter 8. If you recall, we were doing the last part of Chapter 8 on solving inequalities because those inequalities are very similar to equations. So function tables, gosh, this topic is mondo important. You're going to be doing functions for the rest of any math class you take. It's going to show up. So let's talk about what do I mean. So we got a lot of vocabulary for this particular lesson. Remember, anytime we start something new, always a lot of vocabulary. So what on earth do I mean when I say function? So a function is a relationship between what goes in, goes in, and what comes out. Now that sounds kind of rude, doesn't that? Hold on a second. So what we're talking about is this idea of coming up with when I have a value and I put it into like an equation, a rule, I get out a particular answer. Okay, so let me write that again. So each value that goes in has exactly one value that comes out. Okay, so you're going to learn about this at different levels of depth. We're going to be practicing the going in, which we're going to call input. You'll see that in a second, and coming out, and that's going to be output. So basically, we're going to be practicing this idea of using an equation, okay? We dealt with this in our algebra class, okay? So this idea of functions, like I said, is going to keep coming out. So what do we need to be able to get some answers? Well, first off, we need what's called a function rule. And a function rule is the relationship between what goes in and what comes out. So think about it as being like a machine. Oh, and I write the word machine. Hello, and what comes out. So in a machine, you put in parts, and then there's something that happens inside the machine, and out comes a completed product, okay? So what we're talking about here is an expression. So remember, that is numbers and variables and math happening to it, or an equation. And we have numbers and variables and operations, and then it equals something, okay? So instead of what goes in, what comes out, let's give them some terms. So the first one is going to be input. Okay, so the input is the number that goes into, I'm going to box that word, the rule, or the function rule. Okay, so I'm going to pick a number to go in. Now, because I get to pick it, there's some key things about it. First, it's going to be what we call the x value. And because I'm picking it, it's called an independent value. And again, the key about an independent value is you choose the value. So remember, think about it. We did some graphing. You picked the x values, you put it into the function, the rule, the equation, and it calculated the y value. Okay? And that guy is called the output. What came out. So the output is the answer. So I'm going to box him up because it's the result of doing something. You get out of the rule. So it comes on the outside. Okay. So if the input is the x value, what comes out is the y value. If what you put in is independent, you get to choose. The output has to be dependent because the answer depends upon what you put in. Oh, you know what? I wrote value and I want to change that. Sorry about that, folks. We're going to change it from saying independent value to variable. And then dependent variable. And this is this answer. So after we apply our x value into the rule, depends upon what you put into the rule. Okay. So I think that's about all I have room on this screen. So how do we organize the inputs, the calculations to get the output? Well, we're going to use what the title of our notes is, and that's a function table. So let's go ahead and put him over here, and we'll say function table. So I'm about halfway down my page. So I'm still on my first page. So a function table is a way to organize the input value, the function rule, and for me, this is where I'm doing my work. So this is the workspace. And the output. Oops, that's supposed to be all one word. There we go. Much better. Okay. So there's two ways our function table can work. You may be given input values and need to calculate the output values. Okay. So this is going to be real straightforward. We're going to substitute x's into the function rule. When we do that, we'll get out the output. Okay, so this is one thing that can happen, or you may be given output values and need to calculate the input values. That's kind of backwards. Funny I should mention that. That's exactly what we're going to do. So we are going to work backwards we're going to use something we talked about in Chapter 7 with equations by doing the inverse operation, and I'm going to put parentheses in an S because there could be more than one, of the math in the function rule. Okay, so what I'm going to do is go to my page 2, and we're going to be doing some examples. Now, I may have to use 2 screens, but we'll just see what happens. So I'm going to retitle this page. So Lesson 8.1, Function Tables. Okay. So directions are going to ask us to complete each function table. Oops, I don't know where that came from. There we go. Each function table. So first one. The output is 7 more than the input. Okay, so let's remind ourselves. The input is going to be the x value. The output is going to be the y value. Is tells us equals. More than tells us to add and switch order. So I'm going to translate that rule to be y equals x plus 7. Remember when we were doing this in, actually I'm going to change that to green. Plus, and we'll just let 7 be black. We're doing this with our expressions when we were translating and also in our equations, okay? So here's where what my table looks like. I'm going to have a column of x's. So remember, sometimes they'll write just the word input. And then next will come the rule, and this is where I'm going to do my work. And then the result will be the y value or the output. Now, what would happen in future classes is we would take the order pairs we created and we would graph them, okay? So I'm going to pick, or they're going to tell me what to choose. So they're going to give me some values, and my job is to calculate. So let's say they tell me 10, 12, and 14. So I'm going to be given the input, and they want me to calculate the output. So here's what it looks like. Actually, you know what? Let's change these guys. Let's make them colored. And we'll make black be the result. So let's make it, we'll just make it blue. How about that? So 10, 12, 14. So when I'm doing this problem, I'm going to get y equals, and then I'm just going to substitute in 10 for x, and then add 7. And the answer is going to be my output. And I would get 17. And I'm just going to keep doing this. Y equals 12 plus 7 equals, and that's going to give me 19. And then I'm going to try last one here. Y equals 14 plus 7. And that equals 21. Okay, so I used this input-output table, this function table, to help me calculate outputs. Okay, so let's try another one like that. The output is 3 times the input. Okay, so remember what we said. Output is going to be y. Is means equals. We're going to multiply 3 times the input value, which is our x. So we would translate this as y equals, and we'll just make the 3 the same color as the multiplication, 3 times x. And you remember when we were studying this before, we could just write it as 3x. Okay, so let's do our input table again. It's always going to start with our x's, or this is another way I'm going to show you how to write it. So it would say input, and then in parentheses x. Then would come our equation. Give it some room, because that's where you're going to do... Oh, that's a terrible line. Jeez. Let's try that again. That's where our work is going to go, and then we're going to get our output, and that's going to be our y value. Now, theoretically... Oops. Gosh. I'm not very good at drawing today. We have our boxes, and then for our input, let's do 0, 2, and 5 and see what we end up with. So we get y equals 3 times 0. And that is equal to 0. And then let's try y is equal to 3 times 2. And that's going to be equal to 6. And then we're going to do y is equal to 3 times 5. And that's going to be equal to 15. So each input has exactly one output. That's what makes it a function table. Okay, let's see. So I'm going to go on to the next screen, which would still be about halfway down the page here. We're still going to be completing the function tables. Now, these next 2 function tables are going to be different because in my input-output table, they're going to provide me all the information I need. Okay, make this big here. But the strange thing is, they're going to give me the output values. Okay, so I'm going to actually write those in black. So they're going to give me 1, 3, 5. So what's going to happen here is we're going to go this direction. And remember we talked about going backwards? So when we go backwards, 2x minus 1 we're actually going to start with the opposite to what we see. Okay? So the opposite of subtracting 1 would be adding 1. Okay? And the opposite of multiplying by 2 would be dividing by 2. So that's what we're going to do in this problem, is we're going to start with adding 1. So we're always going to do the opposite of adding or subtracting. So I'm going to put this in parentheses. Then we're going to take our answer and divide by 2. So it's opposite the order of operations when we go backwards. That's what working backwards is. So we're working backwards. So I'm going to write that here. Working backwards. So we're going to go this direction. So not only do we do the inverse operations, we're also going to go the opposite direction. So here's what it looks like. We're going to take that 1. We're going to add 1 to it. That's going to equal 2. But then we have to do the opposite of multiplying by 2, which is dividing by 2. And that's going to equal 1. That's what goes here. So then we can test it. 2 times 1 is 2. Take away 1 is 1. When I put in the input of 1, I get the output of 1. Okay, so that's how I test it. All right, so what I just did, again, the test was 2 times 1 plus 1 equals, oh, sorry, not plus 1, minus 1. 2 minus 1 equals 1, and that's exactly what I got. Okay, so let's try the next one. Start with 3. The opposite of subtracting 1 is adding 1. That gives me 4. The opposite of multiplying by 2, or the inverse, is dividing by 2. And that equals 2. So that would be your input, so we can check it. 2 times 2 minus 1. So 4 minus 1 equals 3, and that's exactly right. Yay, okay. Last one. In this table, we have 5. The inverse of subtracting 1 is adding 1, so that gives me 6. And the inverse of multiplying by 2 is dividing by 2, and that equals 3. So I get a 3, so then I can test it. 2 times 3 minus 1, 6 minus 1 equals 5, and that's exactly what it said. So my answers would be 1, 2, 3. 1 pairs with 1, 2 pairs with 3, 3 pairs with 5. So again, over here, when we work backwards, first thing we're going to do is the adding. Oh, let me try that again. Add or subtract. It's the inverse of add or subtract. And the second thing we're going to do is the inverse of multiply or divide. Okay? All right, let's do one more. One more. Input is X. And we could wrap a box around this if we really wanted to be fancy. Maybe I'll be fancy on this one. And we get 3x plus 2. Make it big. And then we have output, which is our y. So I'm going to go ahead and just make this a huge box. Ooh. I'm having trouble drawing straight lines these days. So again, where I start with my numbers is the output. So just as a reminder, working backwards, oops. We do inverse operations. Okay, so looking back at this guy, so the inverse of adding 2 would be subtracting 2, and then the inverse of multiplying by 3 would be dividing by 3. So that's the process I'm going to use on that 17 to figure out the input. What number did I put in for x? So that when I multiply it by 3 and add 2, I get the 17. So this is a faster way of me trying to solve it. So I'm going to start with, let's subtract 2 from it. That gives me a 15. Then I'm going to divide it by 3. And that's going to give me the answer of 5. So, oops, sorry. The output is 17 if the input is 5. Okay? All right, let's try the next one. 20. So the inverse of adding 2 is subtracting 2, which gives me 18. And then the inverse of multiplying by 3 is dividing by 3. And 18 divided by 3 is 6. So I would get an answer of 20 only if I put in 6. All right, last one, and then we'll be done. 29. So the inverse of adding 2 is subtracting 2. We always start with adding or subtracting first, the inverse of what was originally in the problem. That's going to give me 27. The inverse of multiplying by 3 is dividing by 3, and 27 divided by 3 is 9. So if I put in 9, I would get out 29, because 3 times 9 is 27, and then plus 2 would be 29. So again, I can check each one of these. 3 times 5 plus 2. That gives me 15 plus 2 equals 17. Yep, that checks. Next one, we're going to do 3 times 6. If we add 2 to that, let's see what happens. We get 18 plus 2 equals 20. Check, that's what I was told I was going to end up with. Last one, 3 times 9. That plus 2. So now I'm working forwards, right? And I'm going to get 27 plus 2 equals 29. And check, that works. All right, there you go, guys. Good luck with this, and we'll talk to you about it next week. Bye-bye now.